Hi and Assalamualaikum. My group gonna present about liquid penetrant testing, assignment 2 for subject condition-based maintenance. So this is our group members, Zulfikar Hakimi, Muhammad Amiruddin, Ahmad Shamel, and lastly Dayang Nur Hafiza. Firstly, I want to explain about the fundamental of liquid penetrant testing. So, liquid penetrant testing is a non-destructive testing method used to find surface imperfection that could be invisible to the unaided eye in normal lighting. In order to find surface fault in non-magnetic metals and in some situations, polymer liquid penetrant testing is frequently performed. One of the most straightforward and cost-effective non-destructive testing method is penetrant testing. There are a couple technical principles associated with liquid penetrant testing that drive the quality control process, surface wetting, and capillary action. PT is the most effective when the penetrant uniformly wet the surface of the part of test. And then surface tension exists between the liquid penetrant molecules and the inspection surface due to cohesive force. When a liquid penetrant interact with a specimen surface, a cohesive force responsible for surface tension competes with an adhesive force between the molecules of the liquid and the solid surface. This causes the surface to be wet or to have a good wetting ability. This results in a contact angle between the penetrant and the surface of the test surface. If the angle is equal to our grade, then a 90 degrees angle, the wetting is considered to be poor. Next is the procedure to perform liquid penetrant testing. First thing is pre-cleaning. The surface of the test specimen or component is thoroughly cleaned to remove any dirt, grease, rust, or other contaminants. This step ensures that the surface is free from any substance that could interfere with the detection or defects. And then application of penetrant. A liquid penetrant, which is typically a bright color dye or fluorescent material, is applied to the surface of the specimen. The penetrant is allowed to dwell on the surface for a specified period, which allows it to see into surface defects through capillary action. Next is penetrant dwell time. The penetrant is left on the surface for a specific period, known as the dwell time. This time allows the penetrant to truly penetrate any open flaw or defects. Next is the excess penetrant removal. After the dwell time has elapsed, the excess penetrant is removed from surface using a solvent or water rinse. Care must be taken to ensure that the excess penetrant is completely removed without removing the penetrant that has entered the defect. So, after remove the penetrant is application of developer. A developer, which is usually a white powdering substance, is applied to the surface. The developer acts as an absorbent and draw the penetrant out of the defect, making them visible and creating a sharp contrast against the background. And then is visual examination. The surface is inspected visually under appropriate lighting condition. Any indication such as dye bleed out or distinct color contrast are carefully examined and interpreted. Fluorescent penetrants are often examined under ultraviolet is UV light to enhance the visibility of indication. So lastly is post cleaning. Once the examination is complete, the developer and residual penetrant are removed from the surface. The cleaning process ensures that the test surface is restored to its original condition.
Assalamualaikum, my name is Dayan Hafiza binti Awan Khalid. Today I will present to you about advantage, disadvantage and equipment of liquid penetrant testing. For advantage, it easy to learn with minimal training. It also capable of identifying surface crack, pores to small surface discontinuity. Able to test a wide range of materials including very thick and composite items. It's also fast, efficient, portable and inexpensive method for testing large areas and large volumes of part. And it's also able to inspect part with complex shapes. Disadvantage of liquid penetrant testing is it is only able to detect flows that are open to the surface. It cannot examine porous surface and only able to examine clean and smooth surface. It requires direct access to the surface to be examined. Require multiple process steps. Require post-cleaning of part. Requires proper handling and disposal of chemical and potential release of hazardous or flammable fumes with inadequate ventilation. Also disadvantage of liquid penetrant testing. For equipment of operation of liquid penetrant testing is using cloth or paper towel for wiping the surface, source of ultraviolet light, a darkened area or a booth for viewing fluorescent indication, and source of water such as a hose or a bucket. That's all from me. Thank you.
Assalamualaikum and hi. My name is Zulfikar Hakimi bin Zulkifli. Today I would like to present about the equipment operation of liquid penetrant testing, LPT. Liquid or dye penetrant testing is a non-destructive material testing method which use capillary forces to find surface crack or pores and make them visible. It can detect surface breaking, flaws such as cracks, laps and porosity. Next, the penetrant come in two type of liquid, visible dye or the dye will be in red color, and the fluorescent dye. And the fluorescent dye, the color is green yellow. Next is penetrant can be washable with water, removable with a solvent, or require treatment with a emulsifier, that is lipophilics, or it can be called as a oil base, or hydrophilics is a water base. Thank you. Okay, next for the equipment operation of liquid penetrant testing, we have a developer. The purpose of a developer is to effectively pull the penetrant back out of the defect to allow it to be seen by an inspector. The action of pulling back to the surface also allow the penetrant to spread along the surface around the defect, thus magnifying the strength of the indication. And next we have cleaner or remover. Cleaner residue can impact the outcome of the penetrant inspection in much the same way that an oily dirty part can. Penetrant work by locating surface breaking defects, so any substance that might fill the defect, including cleaner residue, must be removed from the part prior to penetrant applications. So these all the equipment that we use in the operation. For the operation, first we use the cleaner to remove all the oil and dirt. Then we spray the penetrant using either red color or the yellow. After we wait for 5 minutes, that we call it as a dwell time. Then we spray the developer, and then we can see the crack that form in the equipment that we testing. Thank you. Next, I would like to present about the application of liquid penetrant testing, the liquid penetrant inspection of medical implant. Now this is we call as a case study. We get it from the journal that we do some research. So this case study show how the LPT was used to verify the presence of any surface indications of flaw on a 67 highly polished knuckle implant sample made of medical grade cobalt chrome alloy. The sample were received in the test ready condition and no pre-cleaning was necessary. The process involved applying a type 2 non-fluorescent penetrant, removing the excess penetrant, applying a dry developer, inspecting the surface under the white light and reporting any indications. So for this study case, the results show at all 67 sample that inspection with no identification found on the polished surface. The case study demonstrates the importance of the evaluating implant that are their final stage of production and ensuring that they have no surface defect that may result in failure to the patient. So the liquid penetrant testing also can be used in the application for medical implant. So not only for the mechanical part like gear and other else part, so it also be using in medical implant inspections. Thank you. Next, for the application of liquid penetrant testing, this is the second case study that we took from the journal and research that we found in the internet. Is dye penetration inspection on formula student car component. When any new parts of any machines or any mechanism is manufactured, it is important to ensure that it has no defect on surface as well as in core. To ensure that inspection of that component has to be done before use. To know that destructive inspection or non-destructive inspection is done. In the destructive inspection, after testing the component has no use, and hence this type of inspection is done after the failure of component to do the failure analysis of those components, and hence this inspection of new material which never be used in operations. So for this case study, I got from the from university in India. They are building a formula car. The students are building the formula car, so they do this liquid penetrate testing of to the part that they have produced, part of the car. For example, that spindle, upright parts for the car, and this testing has been made on a new product that has been produced, and they also have made this testing on the product that already been used, but like the formula car is already crashed. Then they took the part and make the testing on the part to ensure that the part is still in good condition to being used. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Syamal bin Ahmad Kamal Hilmi. So today I would like to present to you about innovation and improvement that we can apply into liquid penetrant testing. So the first one is enhanced penetrant material. So develop new type of penetrant material with improved capabilities such as increased sensitivity, better adhesion to the surface, and enhanced visibility under different lighting condition. This can lead to more accurate and reliable defect detection. The second one is fluorescent penetrant testing. Implement fluorescent penetrant testing which involve using fluorescent dye that emit visible light under ultraviolet or black light. FPT offers better sensitivity and can detect smaller or subsurface defect compared to traditional visible dye penetrant. The third one is rapid penetrant removal. Develop efficient and environmentally friendly technique for removing excess penetrant from the test surface after the dwell time. This can include a new cleaning agent, improved rinsing method, or even self-removing penetrant material that evaporate or degrade after the inspection process. The other innovation or improvement that we can do in liquid penetrant testing is digital imaging and image processing. Integrate digital imaging technologies and image processing algorithm to capture, enhance and analyze the result of the LPT. This can facilitate better visualization and interpretation of defect, as well as enable automated defect recognition and classification. So innovation number 5 is portable and handheld device. Design portable and handheld LPT device that are lightweight, user-friendly and suitable for field inspection. This can improve accessibility and enable testing in remote or challenging environment where traditional equipment may be impractical. So the last one is material specific penetrant. Develop specialized penetrant tailored for specific material or application. This can include high temperature penetrant for aerospace or power generation industries, corrosion resistant penetrant for marine application, or penetrant compatible with composite material. Okay, for the conclusion, liquid penetrant testing or LPT is a valuable non-disruptive testing method for identifying surface defect in materials. Over the years, advancement and innovation have significantly improved the accuracy, efficiency, and reliability of LPT lab work. Enhancement in penetrant materials such as increased sensitivity and better adhesion have led to improved defect detection capabilities. The introduction of fluorescent penetrant testing has allowed for even greater sensitivity, enabling the detection of smaller or subsurface defect. Additionally, the development of advanced application technique ensure consistent and controlled coverage of the test surface. Optimizing the inspection process, the continuous innovation and improvement of liquid penetrant testing lab work have significantly enhanced the capabilities and application of this non-destructive testing method. This advancement contribute to the overall quality assurance and safety of materials, enabling industry to identify and address surface defect with greater accuracy and efficiency. So, thank you.